All right, so when is a relationship not a function? We're going to look at two different ways of determining this, one with a table and then one using a graph. So we'll start with the table, and we're going to revisit this example of the rainfall at the Chicago O'Hare Airport. So remember, we have the month going across the top, and then we have the rainfall amount in inches on the second line. So this first question is R a function of t? So the way that we would write that is that R is equal to f of t. It looks like this. Okay, so this is our independent variable. And let's go back and take a look at our definition of what a function is. So a function takes a number as an input and assigns exactly one output number. So you need to make sure that each input has only one output. So there's kind of two parts to checking that. The first is that I'm looking at these and I see all of my inputs, all of my t values are unique, and that each one only goes to one number. Okay, so it doesn't matter that like these two go to the same number, that's fine. All that it matters is that it only goes to one number. Okay? So R equals f of t is a function because each t only has one output. So yes, for each t, there is only one output. All right, and now let's look at the other way. So is t a function of r? So we would write that as t is equal to f of r. So we would be making r our independent variable, and we want to check and make sure that for each r, there is exactly one output number. All right, so I'm looking at all of these r's, and I see right off the bat that two of these r's are the same. They're both 1.8. And so then I need to look at the t and make sure that they're not going to a different number. And unfortunately, here they are. So here, when r is 1.8, I get a 1. And here, when r is 1.8, I get a 2. So which one do I use? Do I use the 1? Do I use the 2? Do I average them? I don't know. And so for that reason, this is not a function. So this is definitely a no. And for my explanation, what I would say is I would point out this problem here. I'd say when r equals 1.8, t is either or both 1 and 2. Yikes. There can only be one output. For each r value. Right? So t is not a function of r because I just don't know which one of these numbers it goes to. All right, so that's how we would tell that if we were looking at a table. If we are looking at a graph, we're going to use the vertical line test. So the way that the vertical line test works is that you run a vertical line across your graph, and what you're looking for is if there's a vertical line that intersects a graph in more than one point or more than one place, then the graph does not represent a function. All right, so let's give this a try. So here's my vertical line, and as I go across, what I see is that my vertical line here is touching here and here. So it's touching my graph in two places. So just to kind of point that out, there's my problem. So this fails the vertical line test, so it doesn't meet the definition of a function. All right, let's try this cubic. So as I go across here, looks like I'm only touching in one place, one place, one place. So yeah, this one works. Okay. This next graph is called a folium. So as I go across, unfortunately, what I notice is that I'm touching in two places. So I draw my line in here, and I'll show why this doesn't work. Put a no here. And then let's look at this bottom one. So I actually have two parabolas on here. We'll start with this sideways one. So I bring my vertical line across. Once again, You see I'm running into some problems here. Okay, so this parabola is not a function because it fails that vertical line test. This is alumnus gate. We go across here and notice that same problem again. So anytime it's going to touch in more than one place, we don't have a function. And now as I go on across on this one, on the quadratic, it's only touching in one place, one place. Yeah, this one's good. This one passes ours as a function. So if you have a graph, you want to look at this vertical line test. Okay? And really, if you're asked to justify drawing that vertical line and putting those 2 points that match up with the vertical line in your graph is really a really great justification there. If you're looking at a table, what you're looking at is to make sure that each number only goes to one thing, okay, so that they're each unique. If that number goes to two different places, so that goes to a 1 and a 2 here, then you don't have a function. Okay, and that's what you'd want to point out in your explanation. And that is the end of section 1.1.